Hello everyone, good afternoon from my side, or good morning or good evening, depending from where you are logging in. I am João Borges. I am a researcher at the University of Aveiro in Portugal, as well as the conference presence chair at the International Younger Chemists Network. And I am very pleased to welcome you to this fifth workshop of the series on professional development skills. So today we'll be talking about scientific writing and publishing, and we have a great lineup of speakers, as you can see from this flyer. So first of all, I would like to thank you very much for joining us, as well as both speakers for making themselves available and for kindly sharing their extensive expertise on scientific writing and publishing. So together with me, I have Umsel. Can you present yourself, Umsel?
Yeah, I'm Hunsel from, thank you so much. I'm Hunsel from India. I'm working as a scientist in CSIR IIIM Jammu, where we work on the natural product chemistry and the medicinal chemistry. And I'm also excited to be a part of this IYCN workshop on this particular development skill. Yeah, thank you.
Okay, so as I mentioned, so we have really two great speakers that's shown here in the slide. Here I showed the program for this workshop. So we'll be having first a talk from Dr. Vera Koester about scientific writing, and the title will be Writing Scientific Articles. I will present herself just in a few minutes, and then afterwards, so we'll not have questions after each talk, so we'll save them for the panel discussion. But please, you can make your questions during the talks, or for now, if you want to, by putting your questions in the chat. And please send them just to organizers, because we'll be collecting them and making them during the panel to both speakers. So as I mentioned, we'll be having first the talk by Dr. Vera, and then we'll have a talk by Dr. Alison Stoddart that will be talking about scientific publishing, and with the talk entitled The Nature of Science Publishing. And then, as I mentioned, we'll have around 30-35 minutes for the panel discussion. And please put your questions in the chat, and we'll be making them to the speaker during that time. And then I will be just finishing with some closing remarks regarding other events we have been organizing in the scope of this workshop series on professional development skills, as well as other projects in which we have been enrolled. So before going into the workshop itself, let me just briefly introduce our network, the International Younger Chemists Network. So we are an associated organization of the International Union of Pure and Applied Chemistry since 2017. And in here you can see our vision and mission. So the vision to connect and empower younger chemists at the global stage, and the mission to support and advocate for younger scientists working across different fields of chemistry towards a globally sustainable future. So some of you already know how to join, or the criteria to be eligible to join the network. If you haven't done so, you can please go to this link in which you can see you can fill the form to join. So in brief, if you are doing your PhD, master or bachelor across chemical science, so you are eligible to join. Even if you finish one of these degrees and you are under 35 years old, you are also eligible. And even if you are over 35, but you are doing, for instance, chemistry-related degrees, such as a postdoc, you can join if you have done it, if you finished in the last 5 years. So if you go to this website, you can see all the criteria. Even though if you have some doubts, please don't hesitate to connect with us. So you have here our email account, as well as different social media accounts in which you can interact with us and follow to see different events that we'll be organizing and posting during the scope of this professional development series, as well as other workshops that we have been organizing. So without taking further, so I am very pleased to introduce Dr. Vera Koester. Vera, she studied and received her PhD in chemistry from the University of BLSL in Germany in 2003. Then she joined the Wiley, and she's working there from 20 years, yes, since 2001. And first she worked for Wiley for the Ullmann's Encyclopedia of Industrial Chemistry, and then she has been working as well for in different journals covering different fields across the chemistry, as well as close related areas. So since 2010, she is the editor-in-chief of ChemistryViews, that is the science news magazine of Chemistry Europe. So Chemistry Europe is an association of 16 scientific chemical societies that from 15 different countries, and represents over 75,000 chemists. And through Chemistry Europe, you can see a lot of journals that are publishing across different fields of chemistry, such as Chemistry European Journal, ChemMedChem, ChemBiochem, European Journal of Organic Chemistry, European Journal of Inorganic Chemistry, and many more. So you can go through that through the Chemistry Europe website. And without further delays, so I am pleased to ask Vera, so that if you can go over and share your presentation and insights.
Well, hello. Yeah, thank you for the kind introduction. I'm trying to share my screen. So can you see my screen?
Yes, perfect.
Okay. So yeah, thank you, João, for the introduction. And as you've just said, I don't have to say much anymore, as I'm responsible for the magazine of Chemistry Europe. And you've said what Chemistry Europe is. You see the societies on this picture. And the publisher of Chemistry Europe is Wiley-VCH, and that is also my employer. So let's start with how to publish a journal article. Especially if you've never done it before or haven't done it often, it's a big challenge to summarize your research findings in an article for publication in the best possible journal. And yeah, in the next about 15 minutes, 20 minutes, I will give you some tips to make this process a bit easier for you. And I will start with some basic rules, then say a few words on language, and then go very fast to the individual parts of each journal and give you some tips there. So first, basic rules. The first step, or the first thing to think about when you start writing your journal, your article, is to think about what exactly is it that you want to say. So in your article, you want to show the reason for doing your research. You want to show what questions you are trying to answer with your work. You want to show that you have got some significant results, and that your ideas are supported by your data. And if this is not the case, what the alternative explanation is. And all of this you should do in a way that others can easily understand this, because you don't want to confuse your readers. So that's keep it simple. On the other hand, you should avoid the points listed below over here. So you should show that you have a balanced knowledge of the literature. So cite all of the appropriate papers and not just focus on to your own or your boss's or your research group papers. And if another group has got seemingly different or contradictory results to your own results, then please don't ignore them. It is part of the scientific discussion to find out why your results are different. And in the next slides, we'll go to how to avoid exaggeration and jargon and repetition. And then, of course, unethical behavior is something that no one should do, so you should inform yourself about this topic. Language. Yeah, it's I just said that you should explain your research in a way that it's easy to understand. That's one of your main goals. Einstein said, if you can't explain it simply, you don't understand it well enough. And I think this is a good thing also for all of us who are not native speakers. So if we explain simply or explain well what we have done, then we don't need to have fancy language. And if we turn it around, when we are a reader, we know that we don't want to spend hours in trying to find out what this author tries to say. We want to really fast understand what the point is. Yeah, and to make articles easy to read, you need to increase the so-called fluency for the reader. You know exactly what you're talking about because you've spent hours and hours of doing your research. But for someone on the outside who hasn't spent as much time on your project as you have, you need to express your ideas in a way that they can follow. So how can you do this? One good tip is to ask a colleague in the same field, but with different research interests to proofread your article. And if everything is clear to this person, then that's great. Your ideas seem to come across okay. But if not, then perhaps you need to do some more work on that. And another idea is to learn from others. So if you like a paper, try to identify what makes it work so well. Study carefully how the authors constructed their arguments and used their language. So as mentioned before, and maybe I mention it a bit more often, a good advice is to keep it simple. So what does that mean? It means to use the clearest language possible. It means that a sentence should contain one statement or one message, that your sentences aren't too complicated and too long, and that you use simple words. And let's go to an example to see a bit more what this means. Please read this sentence and then decide if this is something you like to read and is easy to understand. Yeah, you probably found out that we can make this more reader-friendly. We start in this sentence with functionalized polythiophene compound 1, and it's unnecessary to repeat that this is compound 1, so we can leave that out. I just said making it simple means that you use simple words. Exhibits can be changed to has. Also shows fluorescence can be simplified. Then again, over here, it appears functionalized polythiophene 1. We had that at the beginning of the sentence, so we can probably get rid of that. And there's also another word, possessing, which we can exchange by a more simple word. And then when we've taken all the necessary stuff out of it, it suddenly is functionalized polythiophene 1, has attractive electronic properties, and fluoresces because it has a benzyl group at a C5 position. And over here, you see that there is information density and the sentence is much easier to understand. So this shows you the way behind that. And George Orwell said, never use a long word where a short one will do. So I give you a few more examples of what we just saw in the example before. So represents, for example, can easier said is, employed, utilized. You can use used. Also some longer constructions like formation of X was not evident. It's more easy to say X did not form, or conducted investigation like investigated. And I guess you can find many of these examples. So then let's come to the last part and go through each individual part of your paper. I'll start with the cover letter. This might be a surprise for you because it's not really part of your paper, but it is your first opportunity to sell your work. And you should tell your editor how fabulous your work is and how excited you're about your work. So address the editor-in-chief and explain the purpose of your study, why this topic is important, which scientific advances have been made. So for example, if your new catalyst makes a reaction X times faster than the old one, then you should say that. And you should also say why, in your opinion, this journal is right for your work. And I guess Alison will tell you more about this. Then the title is read by most people, because everybody who comes across your manuscript first comes across the title and then decides if this is interesting to read. So it has to be descriptive and it has to grab the attention of the reader, because of course you want people to read your article. But on the other hand, you do not want to promise more than your article can really hold. In addition, the title, you have to make sure with your title that the results can be found in the internet, so you have to include keywords. And we look at this with an example as well. So let's imagine we came across an article with the title "Effect of Metal Catalysts on the Outcome of Coupling Reactions with Aryl Alcohols." And when we decide if this is of interest to us, then we find out it's unclear what effect is meant, which metals, what type of coupling reactions, which aryl alcohols. So it's not very specific. And if we would start a search, we would maybe enter ruthenium or CH alkylation, and probably the article with this title would not come up. But if we would have called our article ruthenium trichloride catalyzed CH alkylation of 4 distributed aryl alcohols, then this could have come up with the search, and also it's much easier for us to decide if this is an article of interest to us. The abstract, that's the second most read, because if the title is of interest, then people go on and read the abstract. And this can be scientists, but it can also be press people, or it can be people, scientists from other fields who want to find out what is going on. So in the abstract, you need to give a bit of the background. How does your work fit into the big picture? And why are the questions that you have been working on are important? So why have you done your particular study? And to help find out what kind of results or bits of data or conclusions from your work you should put in your abstract, one tip is to imagine that you have 20 seconds to explain to a scientist who is unfamiliar with your topic what your work is about. The readership of your introduction can still be very broad. And in this section, you should give the background to your work by discussing the results and conclusions of previously published studies. The aim here is to explain why your study is of scientific interest. And then you say what you have done and how your solution should help to solve this problem, or and the introduction is organized to move from general information to specific information, so to your work. And of course, you should emphasize your specific contribution to the field of research. And I have an example over here as well. I said in the beginning that you should say what you want to say, so people want to read facts and then stop. And if we have a sentence like in the yellow box, structure Q has received increasing attention from researchers in the last decade, that might be true, but it's really not very interesting, and it's been written a million times before. So so you should try to think of something that says a little bit more about your work. What kind of attention, maybe why. So you could maybe say structure Q is used in the synthesis of X, and say why X is important. Yeah, so this is again information density. Sometimes you can also write your introduction and then maybe find out that the first sentence is something you can leave out completely. Another thing is selecting the most relevant literature shows that you can appreciate what is most important for your research. So if I, for example, have one sentence and then stick all the references I could find on Q and everything I have done and cite this, then I'm really showing that I'm just throwing in references and I have not really selected what fits my work. And that means, in a sense, that the reader has to do this selection for me, which is never a really good idea. The readers of the results and discussion section are more familiar with your work, but still keep in mind that they might not know everything as well as you do. In this section, you need to highlight how the data you've got through your experiments backs up your ideas, or how you discovered new ideas because it didn't really fit. You have to make sure that you tell this in a story that is easy to follow. So again, this is the fluency thing I just told you earlier. And another thing is that you should make clear the difference between what you can say safely from your data and where you are speculating. Because this is often a criticism from referees, that they say the claims made in the paper are not supported by the data. And it appears often that this is a problem because the author has not made clear the difference between the real firm conclusions that the data support and the speculation. You also should make sure in the discussion that your introduction matches the results and discussions. So that means any claims you made in the introduction have to be supported in the data in this section. Otherwise, this can also come back to you a bit in the referee process. And what you want to be discussing are the most critical and unexpected results, because this is how research is going on, and this is what really interests. So what are your, were your ideas right? Were they wrong? Or did you discover something entirely else? Yeah, and the last thing to say is the experimental details can be kept for the experimental section. And with that, we go to the experimental section. I want to only say a few words over here because I think it's probably the part easiest to write. You just write what you've done. But please bear in mind that people who are reading this section really want to use your techniques. So they are trying to reproduce your results and they may not have done this before. So again, don't assume that everybody has the same knowledge that you have. For this section, it's you should check the journal guidelines, what data are required. Also, it might be a practical tip to summarize the things common to all experiments in the general section, because this makes it much easier to find the main experimental details. And another good tip, I think, is to write this section while you're doing your experiments, because that means you avoid forgetting things and are much more accurate in recording what you're doing. Yeah, and as I said, people who read this really want to do this, so don't keep the small things as a secret. We've talked a bit already about references. References are pretty easy to put together, but reference management software is a tool that saves you a whole bunch of time, so it's advisable to use one if possible. We talked about the over-referencing thing before, so make sure you choose your reference carefully, because this gives the impression that you know the literature and did not just throw loads of references in without thinking about it. Yeah, and the last thing, it's a good idea to recheck the references before you submit. Things change, sometimes fast, and especially if it takes some time from the start to the finishing your paper, it's wise to check again. So to summarize, your job as the author is to help the editors, the reviewers, and the readers to be able to really understand how important your work is and how exciting your work is. Think who you're writing for and keep it simple, be specific and concise. Yeah, and as a last advice, of course, I have to say that however good your writing might be, writing alone won't guarantee that your work will be accepted in any journal. Ultimately, the quality of your research is important for this, but hopefully I've been able to give you some tips so that your work comes across much better. And this was quite a lot in a very short time. My talk was based on tips for writing better science papers. That's a series published in ChemistryViews. It's free to view, to read. I gave you the link over here. And of course, there are also many more books on this topic. I've chosen a few where you can find more information. And thank you for listening.
Thank you very much, Vera, for this great talk on what we should highlight in your papers. So again, I will ask the attendees to please post your questions in the chat box and address them to the organizers only, and we'll be making your questions to the panelists during the panel discussion. So thank you very much again, Vera, for this very nice talk. So now I will continue with the program. So I am very pleased to present the next speaker, that is Dr. Alison Stoddart. So Alison received her master degree in chemistry from the University of Cambridge and a PhD in polymer synthesis for Durham University, both at the UK. And then she has been working in the company for some years, followed by 3 years of editorial experience within the journal Chemical Communications from RSC. And then she started at Nature Research in 2007, first as an editor for Nature Materials, where she takes care of several topics on materials chemistry and biomaterials. In 2016, she launched and was the editor-in-chief of Nature Review Materials. And since January this year, she launched and is the chief editor of this new journal, Nature Synthesis, and as I mentioned, is heading this journal. So today, Alison will be talking about the nature of science publishing. So all about the review process, what an editor looks, or what is the role and what is looking for while he's submitting our papers, and what is behind the process of the peer review process. So without further delay, I'm very pleased to ask Dr. Alison to please share your screen and talk.
Okay, hello everybody. Can you see my screen okay?
Yes.
Yes, perfect. Okay, hello, good afternoon, good morning, good evening everybody. Thank you very much to João and Michelle for the wonderful opportunity to talk to you all today. So I've already had an introduction, so I'll go over this slide very quickly. But I'm a polymer chemist by training who spent a short amount of time in industry as a medicinal chemist before deciding to become an editor, because I had always been interested in that side of things when I was writing papers myself. I spent 3 years at the Royal Society of Chemistry with their journal Chemical Communications, and then moved to Nature Materials and then Nature Reviews Materials, and now I've started with a new venture, which don't worry if you've not heard about it yet, because the soft launch was only last week. It's a new journal coming out in January next year, and it'll be publishing chemical and material synthesis and anything related to synthesis, so automation and those kind of technologies. So first of all, I'm going to take you a little bit through the history of the Nature journals, and in doing that, hopefully explain some of the different kinds of scientific journals that exist. So everybody knows Nature. It's been around over 150 years. It's published many famous studies like the human genome, the structure of DNA. There's also many other Nature babies, as people call them. So Nature Biotechnology was the first such journal in 1983. As well as research journals, there's also reviews journals. So the Nature Reviews series started 20 years ago. In the physical sciences, the first smaller journal was Nature Materials, which obviously is now much bigger. And then 10 years ago was the first open access journal, Nature Communications. And then following that, Scientific Reports, which is not actually Nature branded, but will publish work as long as it's technically accurate. In more recent years, we've had mergers. So we merged with Springer 6 years ago, and various rebranding. We're now called the Nature Portfolio. So you'll hear that more and often now. And then 3 years ago, the communications journals were launched, and the one that's perhaps most relevant for our audience is Communications Chemistry. So as you'll see, there's many journals have been launched over the last few years. So Nature Materials, Nature Chemical Biology, Nature Nanotechnology are perhaps the ones that are most common to this audience today. And really this is accelerated in recent years. We've got Nature Chemistry, Nature Energy, Nature Biomedical Engineering, and Nature Computational Science more recently. So why journals? Really, it is to collate information. So as you can see from this cartoon here, someone's saying they won't go to bed because they found something wrong on the internet. So it's really the job of editors and collating correct information into journals. So what are they? They're established and recognised venues. Nowadays, they're mostly online, but obviously print journals still do exist. And this is where you can archive and find information. If you're a researcher, you know to go there to find certain specific information. So they're selected for validity. So we have a peer review process, which most of my talk will be about today. And of course, I've added an asterisk here because this doesn't work all of the time. It does in most cases, and it's the best method we have. And that's what we use to primarily select what goes into the journal. We also obviously look at interest, quality, and significance. This is subjective. Obviously, some editors and peer reviewers have different opinions of what could be described as being significant. But again, it's our job to try and be consistent as we can and to evaluate manuscripts on this basis. Another advantage of journals is that when articles are published, they are then indexed in databases, so Scopus, Web of Science, PubMed, which makes it much easier for people in the future to find those articles. In addition, publishing in journals adds some value. There is a degree of copy editing, which varies at different journals, but is mostly still there and can help with the readability. There can also be addition of metadata. Perhaps if it's chemical structures, this gets deposited somewhere and there's more information associated with them. And lastly, there's a lot of opportunity to amplify your work to a wider audience through press releases or social media. So Vera's already given us a great talk about what makes a great paper. So this is just one slide which kind of mentions some of that information again, and as she said, it's not just the writing style that makes a good paper. There has to be great research behind that. This comes from asking good questions to start with, and then when you're thinking of the scientific question you want to answer, you've got to think about the experimental design, and you've got to hopefully from those experiments have strong evidence, and from those some noteworthy conclusions. Really, writing a paper is just one part, quite a big process as a researcher. The other large part is writing grant applications, and in this circle you can see how, probably quite simplistically, how researchers do feed their ideas that they get from the publication process back into writing their grants the next time around. And as well as having the great research, we need the compelling story, we need it simply written, as we've just heard, and it's important to write to your audience. So what do Nature editors look for specifically? We're looking for a breadth of interest, so novel conclusions of interest and direct relevance to scientists in other fields. And we're looking for a big conceptual advance, so novel conclusions that change the way people think about a field. So this little cartoon here shows the apple falling from the tree, the law of gravity, but oranges also follow the same law. So the first example is conceptually significant, whereas the second is somewhat incremental. But it's not just that we look for. There has to be logical support for the conclusions. There has to be some kind of mechanistic insight. If you notice something amazing and you want to write about it in a paper, it's also great to be able to understand why it happens. And we're also looking for papers and work that describe that promote other researchers and inspire them to carry on in that field, to really push science forward. And then with other types of journals, so I'm thinking more here maybe about Nature Biomedical Engineering, they might be looking for a significant therapeutic breakthrough. Nature Computational Science might be looking for some interesting code that's being developed, so a significant resource value. So depending on the journal, they may also have more specific aspects that they're looking for. So preparing your submission. Most important thing is to read the guidelines for authors. These will, you can find them on a journal's website, and they vary quite considerably. So this is really the first port of call when you're thinking about where you want to send your work. And it's not important to get every single detail right, but it's the big things like the number of words, the number of figures, the number of tables, the number of references. This just it's a good place to start from to make sure you get those things correct. And also what's important is to read some of the published articles in the journals you want to submit to. You may be doing this anyway, but certainly as you approach a time when you're preparing a submission, look at and read these articles. What are the titles like? What are the abstracts like? What kind of style are they written in? And another thing to look for at different journals is various checklists that need to be filled in before submitting work. So for example, at the Nature journals, anything that's published in the life sciences requires a checklist about in vitro and in vivo experiments. So mostly about statistics and N numbers in experiments. There's also a similar checklist for solar cells. So if you are thinking about submitting to certainly Nature journals and probably similar things at other publishers, this is something you want to look at before you start doing your experiments, so you know what kind of data that ideally needs to be given in the paper to prove that your results are reproducible. And then there's also an editorial policy checklist, which we ask authors to fill in. So this is more about competing interests and authorship, but again, it's something that is required when you submit. So now moving to the life of a manuscript after you've submitted it. And here we can see a person going to submit their article with lots of people in front of them, which are probably the referees. Okay, the life of a manuscript. The papers go into a journal's inbox, and this can be at about 60 new papers a week, but varies considerably across the journals. Within Nature, all the journals are editorially independent, and we don't have any access to information at other journals. But within each team, within each journal team, every editor has their own field of expertise. For example, at Nature Materials, I looked after biomaterials and materials chemistry, and there were two physicists on the team that handled that area, and so on. So when you do receive a manuscript and it's assigned to you, the editors read it, and they also will read the related literature that they can find around that manuscript. And the first decision that we're making as an editor is whether we're going to send it for peer review or not. For the peer review process, as I indicated earlier, it is not a perfect process, but it's the best one that we have. But at least the benefits and the limitations are the same for everybody. So the benefits are you get a check for technical correctness. Because we use several referees, at least there's multiple opinions that can hopefully remove any or reduce any bias in the article. And occasionally fraud is detected at this stage. Obviously the limitations is that it's not exact, and we have to trust, put a lot of trust in referees to be as unbiased as they can. Also, the timescale is unpredictable. You may receive 2 reports very quickly, but then have to wait quite a long time for a 3rd one. And it's very difficult to be consistent with this. But as I said, it's the best way that we have. And by making sure we ask 3 referees, we often get a good set of reports to make a decision on. So I'm now going to break down the peer review process for you. So your paper is submitted to the journal and it goes to the editors, so that's me. And within the team, we will distribute it to the editor whose field of expertise matches that. So sadly, some manuscripts are rejected by the editors. So the percentage of this varies between the journals. When I started off as an editor, this was around 40% on the journal that I worked on, and now it's more in the area of 80%. But of course, you can appeal this decision, and I'll have a slide later which gives you more information about how to appeal. And obviously, the result you're looking for is it go OTR, which stands for out to review. And at this point, the editors will look for referees. Referees provide their reports, and these reports come back to the editor. And then again, the editor makes an editorial decision. This decision may be to reject again because of the reports. And again, there's an opportunity to appeal. But what happens in about 50% of cases that are sent out to peer review is that the editors will request the authors to make revisions. And obviously the authors will see these reports, and we will ask them to provide a detailed rebuttal to the points that the referees raise, and they will revise the manuscript. So revision is then submitted. Again, it goes to the editors. It could be rejected, or it could go BTR, back to review, where it is sent to the referees. Obviously, there's another option, which is where it's accepted in principle, which I'll talk a little bit about later. It does go back to referees, then again, those reports go to the editor. At that point, the editors can make 3 different decisions: to reject, to request another round of revision, or to accept in principle. And obviously, it can go through several rounds of revision requests and revisions back to the editor, but usually we don't want this to go on and on and on, so it would probably be peer reviewed twice before being accepted. There are also transfer options. At most publishers, they have a series of journals that are pitched at different levels, and it can be that if you are rejected from one journal, you can take those referee reports with you to another journal within that publishing house, and a different set of editors can make a decision based on that information. Okay, so a bit more about the peer review process. We do involve as many experts as possible. This is most often 3. If there is something additional in the manuscript, so computational information or crystal structures, then we'll use a referee that has a particular expertise in that. More than anything, we're looking for technical expertise. If you suggest referees as an author, we obviously look into those suggestions, and we would honour any wishes if you wish to exclude referees. When we're looking for referees as well, we need to be look as much as possible that there's no conflict of interest. Obviously, that's not always possible for us to be able to see, but over time, you kind of know the relationships within the community. We're looking for referees that are fair and constructive in their comments, but also we need reports to come back in. So as well as being fair and constructive, it's really important that they are timely. So at Nature journals, we don't count reviewers' votes. So if 2 referees say yes and 1 says no, it's not necessarily yes. Instead, we're looking at the specific arguments of the referee and the comments that they're making. So this does mean that we will overrule the reviewer's opinion if necessary to make an editorial decision. So within the peer review process, in recent years, there's been a lot more variety in models. It's now possible to many publishers to have double-blind peer review, where the papers are anonymised, so the referee can't see the who the authors are. There's also options for referee recognition, so to have the identity of the referees published on published articles. This is an option. And then it's also possible for referees to sign referee reports if they wish to, and they can do this but then not have their name on the published articles. So there's many different options now available to authors and referees. At some journals, they're now starting transparent peer review initiatives where not only the names of referees will be published, but also the reports and the author's rebuttal to those. There's also early career initiatives at many journals where if you want to get involved with refereeing, there's an opportunity to do so. Again, one final point on this slide is to use inclusive language if you are refereeing yourself, so use the pronoun they. So coming to the accept in principle decision that you saw on my earlier slide, at this point the editor will provide feedback on your article to the text and the figures. Once the editor's given that feedback, the author will then submit a final version of the text and high resolution figures. At that point, the editor looks through it again and hopefully formally accepts it and passes it to our production department. At that point, the editor would also think about, could this go on our cover? Are we going to press release it? Could we do a news and views article on it? And then, because the manuscript is with our production department, they make the proofs, send them to the authors. The authors can ask for corrections to be made, and then those are made. Then in a time later, it goes advanced online publication or AOP. Then those publications are then collated into the next journal issue. So I said I would mention a little bit about appealing. So you can appeal after any reject decision. Your paper will be seen again by the original handling editor, not a new editor. At most journals, appeals are taken with lower priority over new submissions. If you do appeal, it's really important to add or provide new data or information or new arguments. So just saying that I want to appeal is not enough. There needs to be scientific arguments within your letter or email back to the editor. And if it was more of a subjective decision on the significance and impact of the study, then perhaps detail why you think your work has the impact that the journal's looking for. Avoid celebrity endorsements saying, oh, so-and-so's read my work and he or she thinks it's fantastic, because editors see that a lot and it's not going to make any difference. And as a final point, it is fair to ask the editor's opinion for suitability at another Nature journal. There's a consultation option that you can opt in or out of at submission. And certainly this is something that is okay to ask. So just some closing thoughts. There's a range of scientific journals out there, and when you've prepared your submission, you as the author are the person that has the decision of where to submit, and you're thinking about your audience and you're thinking about the level of impact and quality or impact of the results and where you think they should go to. But one of the most important things is to do your homework, to read the guide to authors and other articles in journals and prepare your own manuscript with this in mind. Another thing I wanted to mention is that editors are approachable. Many journals, it's completely okay to still have some kind of interaction with them. And another thing I would add is that gaining experience as a referee or an editorial board member, I think would be very, very useful at an early stage of your career. There's many good resources out there that you can read. I've just included one editorial from Nature Chemistry from about 10 years ago on what makes an ideal referee report, and from the On Your Wavelength blog from Nature Physics, how to pitch a review idea. So there's certainly things out there you can read if you're interested to know more about those things. Okay, so thank you very much for your attention, and I look forward to the questions. Thank you.
Thank you very much, Alison, for these great insights on how to better navigate the review process, as well as about the process of editorial decisions after we submit the paper. So we have now reached to the panel discussion. So I will just please ask Alison and Vera to please turn on your cameras and microphones, and I am pleased to hand over to you, Michelle, that will guide the panel discussion. So I would like again to please ask all the attendees. So if you still have questions, please drop them within the chat, send them to organizers only, and we'll be making them to the speakers during this panel. Thank you.
Yeah, thank you, Joe, once again. Am I audible? Yes. Yeah. I think we had a great talk from two great editors, Alison and Vera. Views and opinions and wonderful presentations, and very interesting for an early career researcher like me and many other people who are attending online. There are so many undergraduates, graduates, postdocs, and assistant professors and associate, many across the globe. There was very few interesting presentation with Vera. I mean, Vera, you keep repeating, keep it simple and make it easy. That was very interesting too. And also, we had so much of presentation with, and information with Alison. So we will get into directly to asking some few questions that we have gathered from the attendees online when we get the registration form with them. So I'll get started with this one question from Sri Lanka. His name is Abhirami Ratnakumar. So he is asking how to avoid self-plagiarism. And I am specifically referring to the methodology section. If we follow a very similar or a similar methodology in different articles, how should we rewrite it? So this question will, I think will be first addressed by Vera, and then Alison can also join in and address. Maybe this is a common problem that we are facing in some part of the world. So Vera, can you address this thing? How can we sort out this?
Yeah, so I've understood that it's the methods part, and I would say that there is not the problem of plagiarism, because if you describe your method and you reuse this again, then that's fine. But it depends if you're, self-plagiarism is if you reuse larger parts in your manuscript, or if you if you're doing completely the same method or the same synthesizing the same molecule, then you can use the same thing. But as soon as you do something else, you should or extend more information around that, then that should be similar. It should be different.
Alison, can you come in?
Yeah, and that I agree with Vera. It's not easy to, and it's not necessary to rewrite a method section if the procedure is similar to before. What is important in that method section is that you add a reference, and I would add a reference to the first ever, if you've had 5 articles published with using a similar method for making a backbone that you then functionalize differently, go back and reference the very first one that you published. But yes, self-plagiarism is chunks of repeated identical text, and it's more problematic in the main text much more than in the methods.
Okay, thank you. I know this is maybe, especially for Alison, it may be very tiring to give presentation and then answer the panel questions. But slowly, I think we can catch up. And Alison, you are free to, take a little bit of time to answer them, because you just have presented it. So if you are then we can slowly adjust it. Now I have another question from Patricia Vieira from Portugal. She's asking, what is the best way to organize information, and when we are reading a lot of articles. So this is again, I think Vera will first address, and then Alison can think about it and comment it later. Yeah, Alison, please.
Sorry, I didn't quite catch the question. Do you think you could repeat it?
Oh, okay. So this question is from Patricia from Portugal. She's asking which is the best way to organize information, because we are reading a lot of scientific articles. I think this question will suit Vera, and also then maybe Alison can also get in. Is it okay? Did you get the question?
So it's arranging
which is the best way? Which is the best way to organize information? Because which is the best way to organize?
Well, the best way to organize information in primary research is that you would have, introduction, results, discussion, conclusion, and you want to start off kind of with your introduction being accessible to everybody and gradually get more specific, as Vera said. So it depends on the field how you would organize that information, but you need to think about the reader and feed them little bits of information at a time, and that gets more complicated each time you add another sentence, because you don't want to lose the reader by suddenly introducing a very deep concept. They need to have the background to understand that before you introduce it. So yes, the best way to organize it kind of depends on the story that you're telling, but if you keep in mind drip feeding information to the reader, that will probably get the best results.
Yeah, I would agree with Alison, and it's always good to put the information in that place of the paper where everybody is expecting it, because there are many people who won't read your whole paper and maybe only read the introduction and then the conclusion. And if the information you would expect there is not there, then it's, yeah, you won't reach these people with that. But I also had the idea, maybe this person is also asking if you read papers and want to collect this information so that you later on can refer to this. And I think that's very personal. Everybody has to find out for themselves, but I think it's good to store the information plus where you found that, because later on you have to cite that, and if not, then it's hard to find that again.
Yeah, there is also another question from Catherine from USA. So she is asking, what is the best way to use faculty writing groups or to get beta readers? I think this is more specific to the country. So in some ways, she's asking which is the best way to use faculty writing groups, means how to use the faculty writing groups. I mean, in some universities or in some institute, there will be some faculty groups where they practice those, I mean, they share their writing experiences. So basically, she is asking how to use those facilities. Not directly, not related to the presentation, maybe, but.
Sorry, I think some universities do have kind of writing groups, or they have small courses in scientific writing. And I think if that's what the question is, I think that is very useful. The most experience you get at that level is wonderful. But a large part of learning to write also comes from being edited yourself and getting feedback from peers. So I would say as soon as you start to write your research articles, you want to give them to people to read, either your supervisor or other people in the group, and get feedback in that way, and that helps you rewrite the article to make it a better article. So I think that peer and supervisor feedback is as important or more important than going to kind of faculty led groups. But I mean, any help is great.
Yeah, and I think any experience is also great. I mean, if you have opportunities to improve or to learn how you can express yourself and how you can talk about your science. That makes it then easier if you want to write it in a paper, because yeah, if you train this more to write about science, then it's easier.
Okay. Again, there is another question from Mikkel from Denmark. Mikkel is asking that nowadays there is a growing trend to write articles in active voice instead of passive. What are your thoughts on this? So if Vera and Alison could have any thoughts on this. And nowadays there is a growing trend to write articles in active voice instead of passive. So what are your thoughts?
I think, Alison, you're closer to journals.
So I think scientific journals, I mean, it's what you're most comfortable with. I think the active voice I like personally because it keeps the reader more engaged. There's also ways of using past and present tense to describe concepts that are definitely known and things that then things that are definitely known already by other people, and then using the kind of more present tense for what you're doing in your research. And I think by reading other articles that have been copy edited, so I would go to Wiley or Nature journals, and then seeing how they are written is probably a good way. But really, there's no right or wrong. The manuscript's not going to be rejected because it's in a passive voice. As soon as you look at news type articles and things in ChemistryViews, they're going to be written more in the active voice. But I think with journals, there's still a lot of leeway. You can write in a way that you feel comfortable with, and so yeah, either is okay. I mean, I like the active voice, but that's just a personal preference.
Vera, any comments on this?
Yeah, I can. I can agree with Alison. So what I remember is always describing methods and results in the past tense, and in the present tense all the appropriate facts and background information and your introduction. But yeah, I think Alison is much closer to actual journals. I'm working with a magazine, so don't.
Yeah, actually, thank you. Reminder to the attendees, there are lots of questions coming, so we will not be able to answer all of them, but we are picking a few of them, and then we will, both Alison and Vera will answer some of your questions. Now, another question from Nigeria, Damien Algi. So, Algi is asking, how can I identify high impact journals in my field of interest? How can I identify high impact journals in my field of interest? Very simple. I guess Alison can just straight go to it and answer that.
So I guess high impact depends what you're thinking about the word impact. If you're thinking about impact factors, then that's something that you can go to something like Web of Science and look in your specific subject area for journals, and they publish citation reports every year. But I would be looking for the results that you're reading yourself, and the manuscripts you're reading yourself that you think are really high quality science in your field. If they're published in 3 or 4 journals, and those are your high quality journals, and those are the ones that you read, then that's a good venue for you to aim to publish your work in. So I don't think it goes on just numbers. I think it goes on where you as a researcher go to read the high quality big breakthroughs in your area.
And impact factors can vary very much between different fields. So in one field, an impact factor of, I don't know, 10 is great, and in another one you will never come across 3. So yeah, it depends on where is the research published that you're working on. And
yeah, Alison, in your presentation, you mentioned about to sort out opinions. I mean, while yeah, in your presentation, you mentioned something how to sort out opinions, maybe deciding journals or deciding these things. Do we have to go to the journal impact factor or citation or the history of the journal?
So opinion, so deciding where to publish your work.
Yeah.
So I think it's a combination of different things that would determine where you'd want to send it. And, you know, primarily that is your field. So you're writing for a specific audience, and you also want to consider, is this your big result? Is this, have you been a researcher for 5 years, and is this the biggest result you've ever found? And is, you know, do you feel like you have the backup to support those results? And then you might want to look at, you know, maybe rather than going for a specific chemistry journal, you may want to go for Nature Chemistry. So it's always dependent on how you can start wherever, any journal that you want, and obviously hopefully it gets sent out for peer review and accepted, but if not, you carry on and you submit the article somewhere else. So deciding where your first journal is that you submit to is, I mean, it's your choice as the author. You don't want to waste time, so you want to try and pitch it well. Yeah. Again, this comes from reading the journals and understanding the types of articles that are in these various places.
Vera, you would like to comment on this?
Nothing to add, I think that's...
Okay. Yeah, here another question from Astia. So, see, Katarina from Astia, she's asking, of course, this has been covered in Alison's presentation, but we can still go again with this question. How do editors evaluate the impact of the work presented in a manuscript? How do editors of scientific journals look for in scientific articles? I think this has been addressed in your presentation, Alison, but if you could still comment, and then Vera can have opinion on this.
So primarily we're looking for what the story is, what are the results, and the conclusions from that, and how important those conclusions are. And we're also looking at the related literature in that field to decide how much of an advance this study is compared with the literature that exists already. So, you know, this could, and we're also wanting to see that perhaps it's a broad study. So it's not that you can make one chiral alcohol, you can make, you know, 60 chiral alcohols. You know, the reaction is easy to do. We're looking for lots of different components, and it depends on the actual study, but it needs to be, if it was a chemistry paper, something that is widely applicable to lots of substrates, and you know, perhaps it has advantages, like it's these products have been made before, but perhaps the route doesn't use toxic reagents. So there can be lots of different things, that ways in which a study is an advance over the existing literature, and that's part of you as an author in your paper and your cover letter, to kind of explain why you think it's an advance compared to what's been published before. Because we will look as editors and try and determine it, but if obviously as the authors you have a clear opinion of why it's a significant step up to what anybody else has done before, and that's what you need to describe to the editors and the referees.
I mean, Vera has anything to comment? Yeah.
I can agree with Alison, and this is why it's important to clearly say in the introduction why you're, or in your manuscript, why what you've done is how that fits into the actual research or the field of the research, and what kind of improvement or problem you're solving, or which gap of research you're closing with that. and then how you pick this up again in the discussion, and how clear you can make this.
Okay, thank you again for the comments and opinion. I also have one, not query, but I wanted to know more from Vera. Vera, you keep emphasizing keep it simple and make it easy. So what does that really have? I mean, can you detail it, or can you explain, elaborate a little bit more? I mean, I saw you in your presentation, you say keep it simple, keep it easy. Is it that, I mean, how important is for writing a scientific article?
Yeah, I gave these examples to show you that it's no need to have fancy language in there and blow up your language and yeah. Sometimes we think we are more intelligent, or we seem more intelligent if we really, I don't know, use the most difficult language and make the sentences very long. Then you kind of confuse the reader of your manuscript and the referee and the editor, and they don't really know what you're talking about. Making it simple means that you want that others understand what you're saying, and you're the expert because you do this research every day and know exactly what you're doing. But the others, they just come and, yeah, they never spend much time on that. So yeah, the more easier you make it for this person to read this, the better, because the easier, I mean, we know from ourselves, nobody wants to spend ages to find out what is this sentence going to tell me. So I had this sentence in there to show that if you change a few things, then suddenly the message comes out very clear. Yeah. And I think that's the task of the author, to make it easy for the reader, because we want something from the reader.
Thank you. Now we have another question from Tiago Jardim from Portugal. So Tiago is asking, how can we decide the journal to submit an article? Should the impact factor of the journal be the determinant factor or the targeted audience? It could be translated into, in bracket, it is said, it could be translated into a higher number of citations. I mean, that's what we are having in mind. And if we can choose, should we prefer to publish our articles in an open access journals? This is from Tiago from Portugal. I think Alison can go ahead with this, and then Vera can comment on this too.
So for the first part, you want to go for your target audience over impact factor, of course, because that's who you want to reach. Within, as Vera said earlier, there's the impact factors in different fields vary a lot. So, you know, energy journals have a much higher impact factor than physics journals. So you can't just look for that number within your field. I think again, there's various things you want to look for in a journal, and you know, impact factor is one metric, and doesn't mean that your paper is going to get more citations if it's published in that journal with the higher impact factor. It just means that on average in that journal, articles are cited more on average. It doesn't mean that the consequence is that's going to happen for your article. So you have to think about your audience and where they're going to go. For open access journals, you have a lot of choice nowadays there. Every publisher has a series of different open access journals. That will depend on your funders to a great deal. Perhaps the people funding the research are requesting that the work is published open access. So that's something that you will know as a researcher from the beginning, and then, or perhaps it's something you feel passionately about yourself, that you wish to have your research published in an open access journal, and then you have a wealth of journals that are available to you also.
Vera, would you like to comment on this? How, yeah, and impact factor and all this open access.
Yeah, I think as Alison said also earlier, it depends on where the people are who read your manuscript, where you expect them, and then how you think the value of your manuscript is. So does it fit in a higher journal, maybe also in a more general journal, because this finding is very unique. Then you can, for example, publish this in a journal where they're in a multidisciplinary journal, or is it something that fits better into a very specialized journal? So that depends on where you think your work will find most readers. Yeah, and I think an important point, as Alison said, is submitting to the journal with the highest impact factor doesn't mean that your manuscript is cited many times. But anyway, if you have a great article, then you should aim for the highest impact factor. So.
Yeah. So I have another. I know that there are questions pouring, so we will just stick to some of them, not all of them, but we have few. I guess not much. Now a question from USA, Julian. Julian is asking, can you provide us with some effective strategies to address reviewers' comment?
So
this question, yes, Alison will address well, and then
yeah.
Yes.
Sorry.
How can I address the reviewer in a polite, or maybe how should I address it? How should I handle it in a simple word? How should I handle the reviewers?
So yeah, that is an important part of the process. So a good question to know the answer to. You want to address the referee's comments in full. So if and politely, as you just said, and by full I mean that, okay, you need to do extra experiments if they've requested them and the experiments are sensible. But if you don't agree with the referees and you think that the new suggestions for experiments aren't, then you need to explain why you think that they're not necessary or they're not going to prove or disprove something. So you have to respond to every comment, but you don't necessarily need to act on a comment if it's not the best thing to do. But definitely don't ignore anything that a referee says, because I mean, at most journals, the referees will get to see your replies and then be making another decision. Also, the other referees at that point would be able to see what other referees had said and what the authors had said in response. So you need to keep it as clear and succinct as possible. It can be useful to reply to the referee's comments and then indicate the changes you've made in the text as a consequence. You can also do that by adding the new text in the article in red, so the referees can easily see where their comments have been changed because of the new text that's been added. Yeah, so it's just making sure it's comprehensive and it's well structured. It doesn't need to be, don't make it pages and pages and pages and pages, because that's obviously the referee wants to be able to read it fairly quickly, and the editors also want to be able to get a grasp of it. So
yeah, thank you, Alison and Vera, for the presentation. But there is one question from Maria from Netherlands to Vera. She is asking, how was your transition from editorial to magazine management? Also, what advice would you give to young scientists interested in a career in science communication? Or I will just further the question so that both Alison and Vera can answer, and then Alison can also comment on it, and then we will conclude the question answer session. What is the best way to start a career in scientific editorial world? What are the main challenges and the advantages? Any advice that you can share or give us to the...
Yeah, so for journal editing, if you want to work on a journal, the training is on the job. So you apply after a PhD or a postdoc for this position, and you will receive the training thereafter. If you're going more to a, as she said, a magazine, if you're going more to scientific writing, then you should prove that you have some some experience in scientific writing. So you could, for example, take smaller jobs to write somewhere or start a blog or have anything where you can prove that you've got some experience and show that you can write.
Yeah, I agree with Vera, absolutely. They are two different jobs, essentially. One's more of a kind of journalistic communications aspect, and then journal editing is more managing the peer review process. There is some writing elements, but it's mostly that. So it's important to distinguish they are two very different roles. So if you're interested in a career, which career are you more interested in? And certainly you can go between the two, but if you apply for a journal editing job, you know, we often see people that want to get into science communication, and that's what they say is their motivation, but that's not the job they're applying for. So it's important to understand that distinction and your own wishes of what you want to do in your career. But I mean, essentially, there's lots of editors that end up going into more of the science writing. So it doesn't shut doors. It just, you know, if you're applying and writing a cover letter for a job, make sure you just look at the job description and which kind of job are you applying for.
Yeah, and
once again, yeah.
Sorry.
Yeah, please, Vera, please go ahead.
I came from the journals and then moved on to the magazine. So that is possible, but it's not the normal way. Yeah.
So thank you so much. I think we have a lot of questions, but I think we need to end. Joa has come in. So over to Joa. Yeah.
Yeah, thank you very much to, of course, to Alison and Vera for these very nice replies to different questions. We had really a lot. Really thanks to all the attendees. So we could, of course, we couldn't address all of them, but we collect them. So and we will be emailing them to both Vera and Alison, so that they can kindly reply, and then we'll email them to you, so that to clarify your doubts. So I will now just so finish with the workshops. So just to show you the event that we have been organizing previous to this one. So in the scope of this series on professional development skills, all of these workshops, the previous ones, are on IUPAC, a YouTube channel. You can access them for free. This one that we are finishing will also be there, so we can access all of them. And also we'll be organizing also further workshops. The next one will be on grant writing. It's also a very pressing topic within the scientific community. Also, Alison mentioned that during her talk. And so we are still deciding on the date. In principle, will be by the end of April, but please stay tuned and follow us on the social media for further updates on this. And I also take the opportunity to tell you about this partnership between IUPAC and IYCN. So some of you maybe are already aware. For those that don't, so this is called the Chem Voices. You have here the website if you want to obtain more information. But briefly, what we do is a series of webinars in which we discuss topics that are relevant to early career chemists. So we invite different speakers to cover different subjects, such as you can see here some of the webinars that have been covered in the past, such as on chemists beyond the bench, so alternative careers, resilience, how to foster innovation through collaboration, so the importance of collaboration in driving change, empowering diversity in science. And I can also announce that we'll have the next webinar of Chem Voices by the end of April. It is scheduled for April 29 at 11 Central European Time. We'll be promoting the event via Twitter and LinkedIn of IYCN accounts, so please stay tuned. And in here, as I mentioned, so we invite different early career chemists that are working not only in academia, but also in the industry and in other roles from across the world. And just to finish this workshop, let me thank you again to both Alison and Vera for kindly sharing their expertise and all the insights. It was really great to have you both. Thank you very much. And also I would like to extend our thanks to all the attendees for kindly joining us and for supporting during this initiative. If you have any questions, again, please email us. You have here the email contact. You can obtain more information about the IYCN through the website, and also please reach out through the media. We'll be very happy to talk with you and to discuss further ideas within the events that we have been organizing. So stay safe and see you soon. Bye.
Bye. Thank you.
Bye.